In school, we have a tendency to think of the different subjects that we learn as, for the most part, unrelated. And that's neither wrong or your fault for thinking that, because clearly they are different from each other. But there's two negative side effects to this kind of way to approach education. And the first one is that, and at least this is my opinion, the first one is that you tend to develop a favorite. And that could be due to a variety of factors. Some people become kind of math people, right? So maybe you have a predisposition to math. Some people prefer history. Some people love writing. And so therefore they really like language arts. And that's totally fine. But what that plays into then is that when you're sitting in a class that isn't your favorite subject, for example, if you really like language arts and you're sitting in your math class, it's not very likely that your math teacher is going to start talking about language arts, just as much as it's not very likely that your English teacher or your language arts teacher is going to start talking about math. And so if you're not like, if you don't have a preference towards the subject of the class you're in, you have a tendency to become bored. And so I think what's important is to recognize that all of this stuff that we're learning in high school is not just arbitrarily chosen, right? It's all part of the body of knowledge that it has been deemed like appropriate for you to know before you go off and become, contributing members of society, right? And so, if we think about the interconnectedness between the different subjects, we can start to see that, when we talk about math, for example, I'm a math teacher, so I'm going to talk about math, that there is rich history behind some of the different things we know about math, and it can really open the door to like what's kind of interesting to you suddenly. If you weren't a math person before, but you learn about this actually really interesting stuff that happened in the development of math, then maybe it'll kind of excite you a little bit more. So let me talk a little bit about algebra. Um, Algebra is kind of a branch of mathematics. In the United States, we're one of the only countries that says we're going to go to math class. Most countries say I'm going to go to my maths class, because mathematics is plural, meaning there's several different like kind of disciplines within mathematics. And algebra is kind of one of them. But I still think even that definition is a little bit too narrow. So just history, right? We anthropologists, historians tend to agree that the human, if we think about evolution, the human species started in Africa, somewhere in like North Africa. Then over time we started to migrate, right? I say we as if I was there, obviously I wasn't. Uh, started to migrate, and the only way you can really get off the African continent is through the land bridge that connects the Sinai Peninsula in modern day Egypt. You can walk across this, right? Now there's a Suez Canal there, but before there wasn't. You can just walk across it, and that was the only way that you can get from Africa into what was the Eurasian continent, right? Europe and Asia. And when you get up into this area, what you discover is there is a lot of irrigable land there, meaning land that can be irrigated, because it's a certain kind of soil consistency. There's a lot of rivers around, right? This is the Nile River here, the Tigris and Euphrates rivers here. This area here, actually, I can draw a picture. This area, kind of like here, is what's known as the Fertile Crescent, because it kind of looks like a crescent there, and it became the cradle of civilization. Very specifically, like the Egyptian civilization and the Babylonian civilization, or basically these two areas of the world, Egypt, northern Egypt, and this area right here, which we called Mesopotamia. Mesopotamia means between two rivers, the Tigris and the Euphrates rivers. Those were where the two big civilizations of like the ancient civilizations happened. Because there was a civilization there, a lot of people, when they would move around, they'd be like, "Oh, this is a pretty cool place," because you could farm the land there, and there was not really a lot of reason to move around anymore. And math kind of we think of math as like this just subject you have to study in school, but where did math even come from, right? Like, why did math need to exist? Well, you can imagine scenarios where like you were, say you were the pharaoh in Egypt, right? And you went around and you had your subjects, and you like charge them tax or something, right? It'd be good to know like what percentage of their earnings or their possessions are you going to take from them, or not percentage, but like what portion, right? What ratio? Maybe you're a farmer in Mesopotamia, and you have like you farm wheat, right? You like have wheat, and you want to trade for some cattle or something. Well, what's the rate of exchange between cattle and wheat? And so in about 2000 BC, or 2000 years before the Common Age, that's when we have a record of, in this area, in the Mesopotamian area, in the Babylonian civilization, we have record of people doing math stuff, right? We know that people did math stuff in Egypt also. They built the pyramids there. There was needed to be math for that. But this is the first like real good recorded record we have of it. Uh, People using symbols on writing, having symbols into slates, and those symbols are not the same symbols we use today, but there's evidence through translation that basically what they were doing was algebra, or things like algebra. They didn't call it algebra at the time. In fact, if you go 2,200 years into the future, there was a very prominent port, there still is, but a port city here in Egypt, just to the west of Cairo, modern day Cairo. It was called Alexandria, and there was a guy there. His name was Diophantus, and Diophantus, some of the works that we have from him show him actually solving like abstract level algebra problems. And again, we wouldn't call it algebra then, but there were symbols then. He was Northern Egypt was part of the Roman Empire at that time, and so the symbols he was using were very reminiscent of the symbols that we use now. And so it's easy for us to see, oh, this is obviously what he's doing is what we call algebra now. Go another 400 years into the future, there's evidence of Brahmagupta from India doing similar work. And then it wasn't until about in the would be the ninth century is the 800s, I believe, AD, or in the Common Age, that another guy here in Baghdad, which is at the time was in the Persian Empire, his last name was al-Khwarizmi. I don't know what his first name was. I think it's Muhammad, and then I don't remember the middle name thing. I don't really know how that name works. Sorry, but he wrote a book, and the title of his book, in that title was the word algebra, not algebra, algebra, but the Arabic version of the word algebra. And translating what the meaning of that word is balance. It is a balancing. And so what does that mean? Well, a balance, like think about this, right? If you're now about to take an algebra class, so you haven't not yet taken a class called algebra, maybe some of you have. Okay, but even in a pre-algebra class, I guarantee you that you have done algebra. Because look, here's a problem here, right? Something plus 2 equals 6. We know that that one something, in order to make this equation true, right? In order to balance the equation, make one side equal to the other, that would have to be a 4, right? So what algebra does is it formalizes all of the processes that we can use to balance an equation. And so there's a lot that goes into that. There's a lot of stuff like a lot of the arithmetic rules that we're already used to. Those stay. They're still there in algebra. We have some notation things that we use in algebra. And then there's a lot of extra things. But for the most part, what we're doing is saying, all right, now it's not a box. It's something we don't know. And so in general, if we don't know something, what we should do is we should label it. And the labels that we tend to use are letters. So instead of a box, let's just say it's x. So it's x plus 2 equals 6. And so what algebra then does is formalizes how do we go about manipulating this thing to solve directly for x. To say that algebra is about solving for x is a gross oversimplification. But really, what we're doing is we're taking scenarios, right? We're taking real world things, or we're taking situations, and we're coming up with a way to kind of make those things abstract and then solve for them directly. There's always the possibility of guessing and checking something, right? But wouldn't it be a great tool if we had the ability to solve directly? Um, And now this is algebra, right? And I said before, like it's kind of not super great to think of algebra as like its own branch of mathematics, because ultimately all the branches of mathematics are totally connected. They rely upon each other, right? You cannot have calculus without algebra, but it's not even that you can't have calculus without algebra. It's that you can't have algebra without like basic arithmetic, and there's a bunch of different things that go into what we consider algebra, right? So it's more like you can't have calculus without all the little different things that you learn before calculus. And so as we're going through this year, think about when we're learning new concepts, it's more like we're adding to our toolbox of different things that we know to be true. I always say that mathematics is the language that we use for logic. It is based upon logic. There's nothing in math that is just like, oh, hey, this might be cool. Let's do this. No, it's like this. We do this because for a reason. Everything is a logical decision. Okay, it's in that way. It's kind of a universal language. And so, if we can build up our ability to do these mathematical things, we're also building up our ability, our logical abilities, our ability to reason through things. And so, increasing our mathematical knowledge is also increasing our ability to think critically. It's our ability, increasing our ability to reason. And so, I hope that piques your interest a little bit. And I look forward to. I hope you're excited to learn more about algebra and about math, and we'll try to weave in some of these historical things as we go.